Good afternoon and welcome back to Dr. Logic Awkwardly Does Logic. I promised you some things that you can prove in D, but what I'm actually going to give you is an alternative axiomatic basis for this system. And the way that I'm going to do this is by actually proving you a theorem from our original axiomatic basis, but then show that we could actually have gotten our original basis from taking that theorem as an axiom, i.e., I'm just going to prove an equivalence between two interesting theorems, as a result of which either one can be taken as the axiom because you can always derive the other. So let me bring up my whiteboard. And what I'm going to do is I'm going to first prove in D that it's possible that P implies P. And you might be thinking, P implies P, that's a tautology. It better be possible. And yet, this is not something that you can prove in system K, precisely because we allow dead ends. And remember, at dead ends, everything is necessary and nothing is possible. So how would we go about proving this in system D? So K plus the axiom that necessary P implies possibly P. Well, first, because P implies P is a tautology, so we can just write that down. Justification, propositional logic. The rule of necessitation says, you can stick a box on the front of that. And now we have something that we can substitute in to our axiom. So we will do uniform substitution on the D axiom. And what we're going to do is we're going to substitute in P implies P wherever we have P. So hopefully I've got space. This means that if it's necessary that P implies P, then it's possible that P implies P. But this is a conditional. Line 2 is its antecedent. Modus ponens says, okay, that means we can derive the consequent. So there you have it. In system D, you can prove that possibly P implies P. But now, because I wanted to show to you that this is an alternative axiomatic basis for system D, I am going to take, so I will just kind of subscript this with possibly P implies P. And I will show that from this, you can prove the characteristic axiom of D. And this is all that we need to show that these two formulas are equivalent to each other, and therefore it doesn't matter which one we take as our basis. So the proof of this is actually even easier. We start off by writing our axiom down. So possibly P implies P. Now, because D is built on system K, we know that all of our theorems of K are also theorems of D, including the one that says possibility. If we have a conditional that's possible, then this is equivalent to saying that the antecedent being necessary implies the consequent being possible. So this is our theorem K7. It's actually a substitution instance. I've substituted P in where the original theorem has Q. But now I'm just going to do a little bit of propositional logic. If we have the biconditional or the equivalence between these two, this means that we also have the implication from the left-hand side to the right-hand side. And then you can see from lines 1 and 3 that we've got a conditional and its antecedent. And so therefore we can derive the consequent. So modus ponens lines 1 and 3. And strictly speaking, I probably didn't have to do this line. You could have seen from 1 and 2 because biconditionals are just conjunctions of two conditionals. So there you have it. We have a theorem that involves a possibility operator. So if you remember back to when we were talking about admissible versus derivable rules, and we introduced a rule that was admissible in K because K has no theorems of the form possibly phi. Well, that rule will not be admissible in this logic because we do have theorems of the form possibly whatever. In fact, the fact that we have chosen P implies P is kind of irrelevant. We could stick any tautology in there because all tautologies are equivalent to each other. And so we could have just intersubstituted. So there you go. there aren't particularly all that many interesting things that you can derive within D, so we're not going to be spending too much time doing any more theorems. What is interesting are things that you can prove about the system. So that's what we will turn towards in the next video. Until then, take care. Cheers.